We're asked to solve this equation for h, and don't be intimidated by pi. It's just a number. It looks strange, but that's a number. And there's perhaps a lot to look at here, but basically what you're going to follow is something as similar to this example right here. S is equal to 3h plus 5. If I wanted to solve for h, I have something being multiplied, the 3. I have something being added, the 5. In algebra, in general, not always, but in general, it's easiest to get rid of something that's being added or subtracted first. So to get rid of this 5, we'll just say minus 5 and minus 5. Then I just draw a line here, bring everything down. 3h, that's 0, I don't have to write it. S minus 5. And now I need to get rid of the 3. It's held there by multiplication, so the opposite operation is division. By the way here, notice this line goes all the way under the other side of the equation. If you multiply or divide, you have to multiply or divide everything on each side. That's why in general it's easiest to add or subtract first, because you can just add or subtract one thing if you like. Okay, so now 3 goes into 3 once. H is equal to S minus 5 over 3. And this is your answer for this one. We're going to follow the same pattern to solve this one, even though it looks more complicated. I have all these things are being multiplied together, but all of this stuff has something being added to it, and then all of this stuff is multiplied together, but it's all held together by multiplication. So these individual things are held together by multiplication, but this whole group of things is held here by addition or subtraction. So I can get rid of all of this stuff with addition or subtraction. That's the key. So just as over here, all I had to do was subtract 5 from each side, all I have to do is subtract 2 pi r squared from each side. So minus 2 pi r squared. Then I draw a line under this and bring down what's left. I have 2 pi rh. I'll need a little more room here, so 2 pi rh. That's this part of the equation is right here now. Here's our equal sign. And if I have s minus 2 pi rh, these are not like terms, so all I can do is write s, hopefully, oops, sorry, I'm kind of off the screen here, minus 2 pi r squared. Okay, so already we're closer to having h all by itself. And then what was the last thing we did here? We had stuff multiplying with the h and we wanted to get rid of it, so we divided. Oops. That's exactly what we'll do. I want to get rid of 2 pi and r. All of them are being multiplied. Divide by 2 pi r. Do the same to the other side. Remember, you have to divide everything on the other side. 2 pi r. Two goes into 2 once, pi goes into pi once, r goes into r once, h is all by itself. So you end up with h is equal to all of this. S minus 2 pi r squared all over 2 pi r. This is your answer. You cannot cancel the 2's, the pi's, or one of these r's if it's written this way, because this 2 pi r applies to the s as well as the negative 2 pi r squared. You could write this answer in a slightly different form, but we're perfectly happy with that, so let's go with that. Alright, we'll take a look at another one. This was problem 57. We're also going to solve problem 59. For L, so I have something being added and subtracted. I think you know how we're going to get rid of that. Get rid of this 2w with minus 2w minus 2w. You have 2L left. On this side, here's our equal sign. And then the p and the negative 2w, these are not like terms, so you just have p minus 2w. One more step to get L by itself. Divide by 2. Divide by 2. Up here. 2 goes into 2 once. L is equal to, again, you can't divide this 2 into that because it also applies to the p. Alright, so p minus 2w sits over a 2, and that's our answer. I'll go ahead and show you this could be written in a different way. Okay, we're perfectly happy with that answer. But what this really means, I guess I'll slide it further this direction. Again, this is the answer, but you could write p over 2 minus 2w over 2 equals L. This 2 applies to each term. So it can be written this way. And now, if you want to cancel 2 goes into 2 one time, so this could actually be written p over 2 minus what's left here, w, is equal to L. So maybe I'll circle this in a different color. So we prefer the answer in this form, but if you wanted to go further, this does mean the same thing. And we'll take a look at another one now. Number 62. Oop, we just did 62, then we'll do 65. And this will be, let me see, 65. Oh, I didn't do 62. Oh, for 62 we're plugging in a value. Sorry about that. We're plugging in a couple values. So a number next to a letter means to multiply. If these were negative terms, I would be very careful to put parentheses where the variables are. But since they're positive, I'm really not worried about that. So for the letter P, I'm going to plug in a 30. Maybe I'll use a color for that. So here's our, for P. Okay, I plug in a 30 where the P is. So I write a 33. Let's clean that up. There we go. Equals 2L, they haven't given me L, plus 2, and for W they give us a 6, so I better put times 6. Alright, so this looks kind of strange. Let's clean this up. 30, sorry about that. Equals 2L plus 12. Now let's get rid of this 12. And we're left with 2L equals 30 minus 12, 18. And one more step, get rid of the 2. Divide by 2, it's held there by multiplication. Divide by 2. 2 goes into 2 once, and you get L equals 9. So we solved for L, and it's equal to 9. That's 62, and we're also going to do 65. Alright. So let's slide things up. Alright, they tell us to write 70 degrees Celsius as degrees Fahrenheit. This is already the formula for finding degrees Fahrenheit if you're given degrees Celsius. So all we have to do is plug in a 70 right where the C is. And I'm actually glad that this is a fraction, because I'm going to be able to reduce. Alright, so right where the C is, we're going to put in a 70. And all of a sudden I wish that was a fraction, because I'm going to put 9/5 right next to it. And if I have one fraction, I probably want the what's next to it to be a fraction. So here's our 9/5. Alright, this is 9/5 times C plus 32 equals F. And the reason I didn't make this a fraction is I know that this is going to clean up nicely. 5 goes into 5 once, 5 goes into 70 14 times. So that's a 14. And all I have to do is multiply 9 times 14. 9 times 10 is 90. 9 times 4 is 36. So that's 126 over a 1. So I'm not going to bother put it. Bring down your plus 32. And we almost have F. So 126 and 32. Oh, I guess I can do that in my head. 2 and 6 is 8. I play it safe. 2 and 6 is 8. 3 and 2 is 5. 1. So it would be 158 degrees Fahrenheit if it was 70 degrees Celsius.